Hello class, in this lecture I will try to solve some problems on multiple linear regression which is chapter 14. So I will do practice questions. So I have, let me read the question. The following data was collected to explore how a student's age and GPA affect the number of parking tickets they receive. The dependent variable is the number of parking tickets, the independent variable is age, and the second independent variable is your GPA. So the first thing is find the p-value for the regression equation that fits the given data. So I will copy this data and then I'm going to copy this data first. Copy data, and I will paste this in our calculation aids. So I will go to modules in our canvas page, module 0, and then go to calculation aids and copy of chapter 13-14 calculation aids. So this is our calculation aids. So I will copy this data somewhere here and paste it. So here is our data. So let me cross check this data whether everything got copied or not. Okay, so the question says the dependent variable is the number of parking tickets, which is our y, and the independent variable x1 is our student's age, and the second independent variable is the GPA. So we will go and put so our number of tickets is y, and then age is x1, and this is GPA is x2. That is what the question is saying. Let me cross check again. X1 is age and x2 is GPA. Okay, so I will copy this data. This is my y. I will copy this data and paste it in our y place. So this is my y, and then x1 is my age. I will paste it here, and x2 is the GPA. I will paste it here. So they are asking us what is the p-value. So the question is asking us find the p-value for the regression equation that fits the data. So when they are saying p-value for the regression equation, that is the entire regression equation, not each variable. So they are talking about the entire variable, entire equations. So the entire equation's p-value is significance f. So this is the p-value. So that means we are going to take this value, which is 0.00005 is our answer. So this represents for the entire model. So I will key in that here and then submit it. So that's good. So the next question is for the same problem, They are asking determine if statistically significant relationship exists between independent and dependent variables at zero point 0.01 significance level. If the relationship is statistically significant, identify the multiple regression equation that best fits the data, rounding the answer to decimal. Otherwise, indicate that there is not enough evidence to show that the relationship is statistically significant. So one of the things is I said the regression model is statistically significant if this p-value is less than alpha. So in this case I think they didn't specify the alpha, so we will assume alpha to be points. Okay, they specified, which is 0.01. So p-value, if it is less than alpha, then the regression model is significant. That means I can use the regression model. Again, I am going to type in, so if p-value is less than alpha, that means the model is significant. So this p-value is f significance, that is in ANOVA table you will see this. So in our case, if you see the p-value which we got here is 0.00005. So I will highlight it again with a different color. So that is our p-value. P-value is 0.00005. Is it less than alpha? Our alpha is given as 0.01. So I will do 0.01. So they gave us a significance level of 0.01 here. So this statement is true. So that means our model is significant. That means model is significant. So that means if the model is significant, you have to type in the equation. That is what they are saying. Type the equation. What would be your equation? So if you go to the sheet, our equation, these are the coefficients for our equation. So I will copy this and paste it somewhere here maybe. So let me paste, maybe I will use a different Excel sheet and paste it in a different Excel sheet. So let me copy this again. So this is copy and I'll paste it here. So I wanted only values, so I will just do values. So this is your beta naught, this is beta 1, this is beta 2. So that is what we have. Okay, so our equation would be, I can form this equation, y hat is equal to negative 30.83 plus 1.707 x1 plus 0.233 x2. So that would be our equation, regression equation, because our model was statistically significant. So I will go here, copy those numbers. So I will copy, this is our beta naught, which is or b naught. So that will be here, not there, sorry, this goes here. That is our y-intercept. Our beta 1 is 1.707. so that will be here, and then 0.233 is here. So 3 decimals, I will just do 0.836 and then 707 and 0.233. So I'll submit this. So that's how you are going to solve these problems. Now, instead of asking you to get these values, they have given these values to you. So let's read what's the question. Suppose the following table was generated from the sample data of 20 employees relating annual salary to the years of education and gender. According to the results, is there a salary difference between men and women at 0.05 significance level? If yes, write the difference in salary in the space rounded to 2 decimal places, else select there is not enough evidence. So they're asking you, they gave you these coefficients, this is regression table, they gave you intercept, they gave you the education, and they gave you male or female, this is the value, and they gave you the standard errors, they gave you t-stat. And now if you, as we discussed previously, for each variable, if you wanted to determine whether that variable is significant or not, you'll just look at the p-value and compare it with alpha. If p-value is less than alpha, then you say that it is a significant factor. So last time we discussed, suppose in this case they are asking us male or female, is this factor significant? That is what first thing is we have to determine. So we are looking at p-value. Our p-value is 0.001107. So let me write p-value for factor 2. So that is male female, so that is gender. So the p-value for it is, p-value should be less than alpha, then the factor is significant. So our p-value here is 0.001107. So that would be 0.001107. Is this less than? So let's see what alpha they gave us. They gave us an alpha of 0.05. So let's do 0.05. So alpha is 0.05. So is this statement true? Yes, it is true. So you are saying the factor is significant. So if the factor is significant, then what value they are saying? Okay, they are saying if yes, write the difference in the salary. So if this factor is significant, by looking at this, that means the difference in the salary would be by the coefficients, which is 4345.62. So I will type in that, and that's our answer. So now they are asking you take this same equation and then they are asking you to look at what would be your expected salary with no education and no experience. So as you see, our formula, I can copy this again. So your formula would be this plus 2 3 this times x1 plus this times x2. So I will write the formula maybe. Let me see what would be the formula. So the equation would be y hat should be equal to 14277.24609 plus 2352.8868 x1 plus 829.5272 x2. So when I say no education, that means x1 is 0, x2 is 0. So I'm only left with the y-intercept, which is 14277.246. So your y hat would be 14277.24609. So that will be your answer. So this is a y-intercept, which is this value would be your answer. So how much would you expect your salary to increase if you had one more year of education? So usually if you see, the coefficient is what it will increase by. So if you see our equation, if I had one more year of experience, this I discussed this in simple linear regression, that my slope, if I increase the value of x1 by 1, the y value will increase by the slope, which is 2352.8868. So education is this, so I will say my y will increase by this value. Okay, I will do some more problems on this. Okay, so the question is, based on the ANOVA table, is there enough evidence at 0.05 level of significance to conclude that the linear relationship between independent and the dependent variable is statistically significant? Now we are saying, is there any relationship that is statistically significant? That means I'm looking at this value again, this is p value, it should be less than alpha to say there is a significant relationship. So here my f value is 0.451847. So I will write my f value, f significance, that is p value, is 0.451847. So if p value is less than alpha, then it is significant. So they gave us alpha, which is going to be 0.05. So alpha is 0.05. So 0.451845, is it less than 0.05? So this statement is a false statement. So that means if it is if this statement would have been true, it is significant. Now it is not significant because this statement is false. So you are saying no, this is not significant. So again they are saying, let me see, the following table was generated from the sample data of 10 newborn babies. regarding the weight of the mother at birth, the weight of the father at the birth, and the weight of the baby at the birth. So the dependent variable is the weight of the baby. The first independent variable is x1 is the mother's weight, and the second is independent variable is the father's weight. So write the multiple regression equation for the computer output given. So again, if you want to write the regression equation, this is our intercept, this is our coefficient, and this is our the coefficient for variable 2. So y hat, that is y hat would be child's weight, that will be equivalent to your intercept plus mother's weight. So I have to put minus here. So father's weight again, it usually doesn't take when you put the value, because they are saying your character is not required in the answer, but so you will put this, so that would be your answer. I will submit this. So the next thing is please indicate if any of the independent variables can be eliminated at 0.05. So again, whichever factor which has p-value less than alpha, that factor is important, and whichever factor that has p-value greater than alpha, that factor is not important. You won't touch intercept at all, so intercept will always be there, so don't think about intercept. So I'm looking at p-value for mother's weight. So this is the p-value for mother's weight, and I'm asking myself, is it less than 0.05? So if it is less than 0.05, then it is a significant. If it is more than 0.05, it is insignificant. So currently I will go here and then kind of write the p-value for mother. So the p-value for mother is given as 0.00847. Is it less than the significance level here is given as 0.05. So I will go and ask myself, is it less than 0.05? And this is a true statement. So yeah, 0.00847 is definitely less than 0.05. So this factor is significant. How about this is mother's weight? So let me do the same thing for father's weight. So father's weight, the p-value is 0.371742. Is it less than 0.05? This is a false statement. 0.37 is not less than 0.05, so it is not significant. So father's weight can be eliminated from the equation. So if so that means father's weight is x2, so we can eliminate the variable x2. So write the multiple linear regression for this. Again, the following table was generated for college students regarding number of parking tickets the student receives in a semester, the age, and the GPA. I think the dependent variable is the GPA, the independent variable is number of parking tickets, and the second independent variable is the student's age. So the GPA is your y hat, and they're asking you to write the equation. So that would be 11.584, and then your x1 is the number of parking tickets, so that would be this one. So I will do again, I have to type in minus here. So again, student's age, I will type again, I have to type negative sign here. So that will be my regression equation. And then please indicate if the independent variables can be eliminated at 0.01 significance level. So again, we are asking if this value here, is it less than 0.01? Yes, 0.009 is less than 0.01. So that means this is an important factor. Then again, 0.005, is it less than 0.01? That is true. So 0.005 is less than 0.01. So both factors are important here. So you will keep all the variables. So now they gave us this question. Suppose the following data were collected relating to the selling price of a house to square footage and whether or not the house is made out of brick. Use statistical software to find the regression equation. Is there enough evidence to support the claim that on average brick houses are more expensive than other types of house at 0.05 significance level? If yes, type the regression equation in the space provided with the answer rounded to 2 decimals, else select this is not enough evidence. So the thing is, I need to copy this data. Let me see, I will copy this data and paste it in our calculation aids. So again, I am going to get rid of this. I'm going to get rid of this and then paste our data. So now one of the things I wanted to tell you here is, if you see brick, it represents 1 and 0. If a house is if a house is made of brick, they will use 1. If the house is made of if the house is not made of brick, they will use 0. So the thing is, because you have two classes, we will introduce only one variable here. So usually in this course, you will have only two factors, two classes, and you will kind of use only one variable. So the price is your y, square feet is your quantitative x, and brick is your quantitative y. So I will kind of again put these values into our question and see if we can get a regression equation. So price is your y, so I will copy this and paste it here. And then square feet is your x1, and then your brick is your x2. So if you see, this represents the slope of x1, which is square feet, and then this represents the next one, slope, which is brick. So what the question is asking us to do is, if you read the question carefully, use statistical software to find the regression. Is there enough evidence to claim that on average brick houses are more expensive than the other types of brick houses at 0.05 level? If yes, type the regression equation with answers to round it to 2 decimals, else select there is not enough evidence. So what they are asking us to do is to look at the uh, the brick factor, so that is the slope, and look at the p-value here. So let me look at p-value. So that is your p-value 0.0103. If it is less than alpha, that factor is significant, then you will type in the equation, otherwise you are not going to type in. So let me see what alpha did they give. I'm sorry for this. What alpha did they give? The alpha is 0.05. So let me uh, so let me go here. So again I am looking for brick p-value and looking for p-value less than alpha, then the factor is significant, otherwise it's not significant. So alpha is given as 0.05. Is this, what is the p-value? So let me see the p-value which we got. So the p-value we got here is point, again I can highlight it with a different color, maybe blue, I'll use, yeah, 0.0103. This is 0.0103. Is this statement true? 0.0103 is less than 0.05. This is a true statement. So that means that factor is significant. So that is a significant factor. So if it is a significant factor, they are asking us to, if yes, type the regression equation. So now I have to type the regression equation. So the regression equation usually we get from these coefficients, from these values. So the first thing is the intercept is 105,435.281. So I will type in this here, and then the square feet, I will type here, and then the brick. So that is this value. So I'll submit this. So this is again in this question, if you see, suppose you are interested in using regression analysis to estimate an MLB player's salary using the following independent variables. If the pitcher is a if the player is a pitcher, the player's nationality, the player's age, the player's career strikeouts, the player's games played, and the player is on the New York Yankees, which of the following independent variables are indicator dummy variables? So they are asking you what are, when they say identify the dummy variables, that means which variables is a qualitative variable. So if you see the first one, if the player is a pitcher, so this you can answer by yes or no, so that is a qualitative variable. The player's nationality, so that is a country, so that is also a qualitative variable. Player's age, that is quantitative. Player's career strikeouts, I think it is a, kind of how many strikeouts they have, that is also quantitative. The players career games played, so how many games they played is also quantitative. And then the player is on the New York Yankees, this you can answer with yes or no questions. So those will be your dummy variables. So again this one, they are asking you to, you have 20 sample employees relating salary to years of education and gender. According to there is a salary difference between men and women at 0.05 significance. If yes, write the equation in the space. Otherwise you say uh, there is no evidence. So if you see 0.05, so write the difference in salary. So they're asking you whether this male and female variable is significant or not. So if you see 0.003 is less than 0.05, so that means this factor is significant and the salary difference would be this. So this is how you will be solving all the problems in Hawk's learning. Usually you have to remember for the entire model p-value, if it is less than alpha, it's significant. For the individual variables, if you have a p-value less than alpha, then also it is that factor or that variable is very significant. And then the coefficients represents the regression equation. So this concludes my lecture on multiple regression. Thank you.